Good afternoon, student. Our today's topic is data communication concept. Okay, that is our computer network subject. In that, our first topic is data communication concepts. And in this topic, we will study the concept that is data transmission. We'll study what is data transmission, and transmission is your media, or you can say that medium. Okay. Next is your digital and analog transmission, difference between digital and analog transmission. And there is an example of digital signal that is converted to analog signal, and that is done by a device named as modem. Okay, modem is your modulator, demodulator. And this device is used to convert your digital to signal to analog and analog to your digital signal. Then after that, we will study parallel and serial transmission. And in this parallel and serial transmission, it is further categorized as a synchronous and asynchronous communication. After that, we will study the modes of communication or mode of transmission. Okay, or you can say that transmission modes. And in that, there are three types of transmission mode. First is your simplex, half duplex, and full duplex. Okay, this we will do with an example. What is simplex mode is, what is half duplex is, and after that, what is full duplex. Okay, first of all, what is a data transmission? Okay, transmission, I have said that it is a medium or a media. First of all, data transmission is the transfer of data from a point to point, often represented as an electromagnetic signal over a physical point to point or point to multi-point communication channel. Okay, means transmission is your signal is transmitted through a media or a channel so that your data can be transmitted from a sender side to a receiver side. Okay, here the word is used that electromagnetic signal means your data is in the form of electromagnetic signal that can be analog or that can be a digital signal. And that data, it can be analog, it can be digital, that is transmitted by a physical point to point or point to multi-point. Means there is a single sender, that is first point, and there is a receiver, that is second point. That is why the word is used point to point, sender to receiver or sender to multiple receiver. Okay, if we call to an individual person, okay, if we call a WhatsApp call or a telephonic call, that is a point to point communication is there. Okay, we are transmitting a data, it is in the form of analog. Our voice is going from a sender side to a receiver side, and the same way from receiver side to the sender side. That is a data transmission. Okay, and point to multi-point means we are calling as a group. Okay, group call is there. Okay, at a time single person is speaking, other person of a group is listening to them. Okay, sender and receiver is also there. Okay, so a data transmission is a transfer of data from point to point or point to multi-point communication channel through a channel. A communication channel refers to the medium. Okay, now the what is channel is a medium or media. Okay, a communication channel refers to the medium used to convey information from a sender to a receiver. Okay, data is transmitted from a sender side to a receiver side, and it can be fully or partially the medium. Okay, medium can be your full medium or it can be a partial, and this concept, the full and a partial, we will study in the transmission mode. Okay, I've told that there is a transmission mode or a mode of communication is there: simplex, half duplex, and full duplex. In that, we will study what is full or partially mean. Okay. So here is the example. This PC is your sender side. Okay. And from here, from the sender, the message is sent through a communication media or a transmission media. And the transmission media can be a wired or a wireless. So in next lectures, we will also study the transmission media. I have also told in the previous lecture, there is a two type of transmission media: wired and a wireless. Okay, so symbol is given. This is your wireless symbol, and here is a wired cable shown. Means there is a two type of mode: wireless as well as wired. And this is your transmission media. Okay, your data is transmitted through this media from sender side to receiver side. Okay, and the word is written protocol, and the protocol word also defined that protocol is your set of rules. Means there is a rule made: sender will send the data in a particular form in a particular time to the receiver side, and receiver can receive it or check it whether the data is accurate or not. Okay, further in your presentation layer and your transport layer, in that layer, in part 4 concept of your syllabus, we will study how we will check our data. Okay, that is sent by a sender and received by a receiver, that data is correct or not. Okay, that we will study in our part 4 concept. Before that, the concept is data transmission. Example of your channel means your transmedia media can be a copper wire. Transmission media can be transmission media, you can say, or you can say that a channel, communication channel. It can be your copper wire, optical fibers, or wireless communication channel. Okay, your cable TV, your cable, okay, a dish or your cable or your channel you will receive is through a copper wire. Okay, that is your coaxial cable. In coaxial cable, there is a copper wire in it. Okay, and optical fiber is used in your modems, in your internet. Okay, for better speed. That wire, that broadband is connected with your optical fiber, and the Reliance is using an optical fiber concept now because it is most faster than copper wire and a previous telephonic lines wires that is used through communication. Okay, then a wireless communication channel is there. The tower is placed nearby you, and through that your wire signals is sent from a sender side to receiver side. Okay, that is your transmission media are. Okay, and the term is data transmission. Data transmission is to transfer your data from sender side to receiver side. And here is a diagram. Here the sender is sending a data. You know that your computer will generate a binary signal or binary data, and here your data is in the form of binary, and that binary is your digital data. Okay, computer reads binary data, it creates binary data, but modulator demodulator means your modem, your system is connected with your modem, that modulator convert your digital signal to analog signal, and that analog signal is further transmitted through a media or a channel. Okay, that is wire. That digital signal is converted to analog signal and further transmitted through a channel, and at another end there is a demodulator, means modem is there, that demodulate the analog signal into digital signal, and further receiver will receive that data and show as sended by a sender. Okay, in this manner, your data is transmitted. Sender will send it, receiver will receive it, and further there are different medias are placed. Modulator will convert your data. Okay, modem. Modem stand for modulator, demodulator. Okay, and then same way, if your data is sent in a digital form, a system generates a digital data, then there is an encoder. Encoder encode your data and send that data in the form of digital manner through a channel, and further decoder decode it, and receiver will receive the exact data that is sent by a sender. In this manner, you will send your data and your transmission media and your channel will work. Okay. Next is your what is digital and analog transmission. An analog transmission is your transfer of continuously varying analog signal over an analog channel. Okay. Analog transmission is a media, and in this media your continuous varying analog signal is transmitted and transmitted through an analog channel, that is your wire. Okay, through wire you can send your analog signal. Okay, an example of analog signal is your voice. When we will speak, the voice that is transmitted, that voice is in the form of analog, in a wave form. Okay, digital communication or digital transmission is a transfer of discrete message over a digital or a analog channel. Here, digital communication is your discrete message in the form of 0, 1. Okay, the diagram is shown. First one is your analog signal, and in this your frequency is shown. Okay, in your this is your frequency is red one according to time. Okay, but at the bottom one, this one is your digital signal that is in the form of 0 and 1. Okay, high 5 volt means it is 1. If it is 0 means it is 0, binary 0, and high it is 1. Okay, this is your digital signal is, and through digital communication your data can be sent or transfer in the form of discrete message over a digital or a analog channel. Your digital communication can be sent through a digital as well as from a analog channel. Okay, but there must be a converter. Okay, that converter is your modem. A data transmitted may be digital message originating from a data source, for example, a computer. Okay, your digital data is generated by your computer in the form of 0, 1 or by your keyboard. But when you want to send your data to a receiver, your system have a encoder. That digital signal is transmitted or encode in a binary form and further transmitted to the receiver side, and receiver will decode that if it is digital. But if you want to send your digital to a analog form, then you have to use a modem. Okay, here the example is there. If you want to send an analog, if your channel is analog channel, then you have to use a modulator that convert your digital signal to analog signal. If you have a digital channel, then your data that is already in the binary form, then it can be encoded and further transmitted through a digital channel. Okay, this is the best example. Next is your analog signal carrying analog and digital data. Here, your analog data is your voice sound. If we speak, that is in the form of analog signals or your analog data. Okay, an example is your telephone. Okay, telephone lines. When we will use these telephone line, our voice sound that is in the form of analog, your signal is in the form of analog, that is transmitted from a sender side in a analog form, and further receiver will receive that call and listen that voice in the form of analog signal. Okay, and further at bottom there is a conversion, that analog data that is in the form of binary voltage 01 form, modem will convert that digital signal to an analog signal. Okay, and vice versa. If it is analog, then it is converted to digital with the help of demodulator. Okay, then modulator modem is your, it is stand for modulator demodulator. Modem stand for modulator demodulator. It is a hardware component. Okay, it is a hardware component that allow a computer or another device such as a router switch to connect to the internet. Your set-top box, okay, Videocon set-top box, your Airtel set-top box, or your modem or your router switches, they work as a modem. Okay, if your data is in the form of digital, it convert into analog, or analog is there, it will convert to a digital. Okay, next point is it convert or modulates an analog signal from a telephone or a cable wire to digital data. It converts your analog data to a digital data. Analog is your frequency and digital is your 01 form, binary form. Similarly, it converts digital data from a computer or other device into an analog signal that can be sent over a standard telephone line. If it is digital and you want to send through a telephone line, then it is converted by a modem so that it can travel through a analog channel. And here are the examples of your modem, your router, your access point, okay, or your set-top box are example of modem. Okay, they will convert your data. If it is digital, it will convert into analog. If it is analog, it will convert into a digital. And here is also an example is if your computer, if you want to send your data from a computer, okay, and computer will generate a binary data, and after that there is a modem, okay, that modem will convert your digital data to binary, or sorry, digital data to analog, and after that there are number of computer, and further that send the data to an another sender receiver side. That data will be converted into a analog form because our transmission media is wired. Okay, here it is, the transmission media is your analog transmission media. So the digital data is transmitted, okay, transmitted, or you can say converted into an analog form. Further, that data that is converted to analog form, that is further transmitted through an analog transmission. Further, there is a analog multiplexer. Multiplexer is your, to perform a multiplexing means collecting the data from a multiple senders. Okay, collect that data. Okay, then and your analog data is in the form of frequency. So here FDM stand for frequency division multiplexing. Okay, FDM stand for frequency division multiplexing means your multiple data from a multiple sender get multiplexed and further transmitted through a transmission media, and that media is analog, and further collected by a FDM, that is frequency division multiplexing, and distributed to the relevant receivers. Okay, this is conversion of your digital signal to a analog signal. Okay, and further, next example is your analog to digital. Your telephones generate analog signal and they will encode, okay, and get multiplexed and further send to an antennas, and antenna further transmit that data in the form of digital, okay, 0 1 form. So here TDM is your time division multiplexing. TDM is used to collect your analog signals that is decoded in the form of digital, okay, and further transmitted to your antenna. Further antenna will transmit that digital data. Means here analog data is converted into digital data. Okay, further TDM and FDM we will study in our part 4 concept. What is FDM, what is TDM? But full form is FDM stand for frequency division multiplexing. TDM is your time division multiplexing. Okay. Further, next is your classification of transmission mode or taxonomy of your transmission mode. Okay. Transmission mode is further classified into two parts: parallel transmission mode and serial transmission mode. And further, serial is further characterized into your asynchronous, synchronous, and isochronous. Okay, the most important is your synchronous and asynchronous in your serial part. Okay, transmission mode. This is the classification of transmission mode. For it categorized into two parts: parallel transmission mode and serial transmission mode. Okay, first of all, we will study that what is your transmission modes are. A transmission mode is the manner in which data is sent. Okay, the manner in which your data is sent, that is your mode, transmission mode. Okay, transmission mode can be divided into two fundamental categories. First is your parallel, second is your serial. Parallel is your parallel stand for multiple lines. Okay, multiple wires are there. If there are multiple wires that are placed parallelly, means we can send multiple bits from that. So parallel means multiple bits are sent at the same time. So, and serial is one bit is sent in a sequence manner. Okay, serial means in a sequence manner, one after another. One bit is sent at a time. Okay, and parallel is multiple bits sent at a time. Here are the example. First of all, we will go for a parallel transmission. Parallel transmission is your each bit use a separate wire. Each bit, if there are 8 bits, example is given, if there are 8 bits, then there will be a 8 channel or 8 wire should be there to transmit that data. Each wire or each channel transmit a single bit. Okay. To transmit data on a parallel link, a separate line is used as a clock signal. So in your parallel transmission, a clock signal is used to transmit your data. This serves to inform you that a receiver when data is available. Okay, clock signal is used so that receiver acknowledge or a receiver can receive that your data is ready to send. That is why clock signal is used in your parallel transmission. But in your serial, this clock signal is not used. Okay, I will repeat it again. This serves to inform the receiver when data is available. In addition, another line may be used by the receiver to inform the sender that data has been used and it's ready for the next data. Okay, the clock signal is also used so that the information is sent to the sender side that data has been used by the receiver and you or sender can again send that data. That's why clock signal is used. Okay, here is a parallel data transmission. Examples: bit 0 is sent by a single line, bit 1 is sent by a second line. So at a time, at a single time, we can send a multiple bits, okay, at a single time. It is faster than your serial transmission mode. Okay. Next is your serial transmission. Each bit is sent over a single wire, one after another. Okay. Please wait a minute. In your serial transmission, each bit is sent over a single wire, one after another. Means here it is a single channel, single wire is there, and from that your bits are traveled in a sequence manner, one after another. So in a serial mode, your transmission speed is less. Okay. Usually no signal lines are used to convey clock. There is no signal lines are used to convey, means there is no clock signal is there. There are two type of serial transmission is there, and that is your asynchronous serial transmission and synchronous serial transmission. Okay, parallel transmission is obviously faster. Okay, because in your parallel 8 bits are transmitted at the same time. Okay, but in your serial transmission, one bit at a time it's transmitted. Okay, in that all bits are sent at the same time in your parallel transmission, whereas in a serial transmission is slower because only one bit can be sent at a time. So parallel transmission is very costly for anything except shortening. Okay, shortening means your parallel transmission is costly. Cost will be more because more wire will be used, and it is mostly used for short network. Okay, short network means between a room. Okay, because more wire will be used, so that it is used for short links, short connections. Next is your difference between parallel and serial transmission, already explained. Serial transmission speed of data transfer is slow because it will send one bit at a time, one by one. Okay, so speed will be slow. Parallel speed of data transfer is fast as compared to your serial. Number of lines in your serial transmission, only one line, one media will be used. But in your parallel transmission, n number of lines will be used. Okay. Number of bits per clock in serial, one bit at a time. Okay, in parallel, n bits at a time. Cost in your serial transmission low as only one line is there. Okay, one channel will be used, but in your parallel, high lines are used, means number of lines are required. So if number of lines or number of channels are required, then cost will be maximum, means number of wire will be used. If number of wire will be used, cost will be increased. Then last is your application in your serial transmission, long distance communication like two PCs. Okay, if you want to connect two PCs from one campus to another campus, you can use serial transmission. But parallel transmission, short distance communication like system and printer. Okay, if you want to connect a printer, then your parallel transmission will be used. Okay, and at the bottom there is an example. Okay, this is your sender side. The data is sent in the form of bits, and it is one by one, and the receiver will also receive that bit one by one. For parallel communication, Okay, multiple bits can be sent by a sender and receiver can receive a multiple bits at the same time. Okay, next in your serial transmission, there is an asynchronous serial transmission and synchronous. First, we will study what is asynchronous serial transmission is. Data bit can be sent at any point in a time. Okay, data bit can be sent at any point in a time. That is your asynchronous transmission is. At any time means if I have message to you, message, okay, then you can receive that message or read that message at any time. If I am sending that message at 2 p.m., you can read that at 3 also, at 4 also, at 2 same time also. That concept is called asynchronous serial transmission. Okay, data bits can be sent at any point in time. So next point is stop bit and start bit are used in your asynchronous serial transmission. Your start bit and stop bit means if your data is in the form of 8 bit, before that 8 bit there is a start bit, and after your that data is there is a stop bit, means total 10 bit will be there. First one is your start bit and end one is your stop bit. Okay, stop bit and start bit are used between data bytes to synchronize the transmitter and a receiver and to ensure that the data is transmitted correctly. Why this start bit and stop bit is used? So that the receiver will receive that data that is sent by the transmitter or a sender side. It, if there is a start bit or stop bit while receiving that data at a receiver side, then receiver will acknowledge that that data is accurate. If there is any bit that is destroyed or number of bits are not sent accurately, then it will a problem. Okay, then means if it is 10 bit, at a receiver side it is received only 9 bit, or if there is not start bit or not any stop bit, then means that data is get corrupted or it is in a damaged form. Okay, that is why your start bit and stop bit is attached with your data. The time between sending and receiving data bit is not constant. Here the data timing is not constant. The example I have told you that when I have sent it that data at 2 p.m., you can receive that message or uh, read that message at 3 p.m. also, at 4 p.m. also, means data time or your time is not constant. But in synchronous, this time is synced. Okay, that I will explain in next slide. So gap are used to provide time between transmission. Example of your is file transfer, email, or World Wide Web. Okay, we can access any web page at any time, and that data is placed at a server. Okay, and that is in the form of asynchronous transmission. Okay, email. I have sent it a mail at morning. Okay, that mail is in your inbox. You can receive that email or read that email at any time. Okay, that is an example of asynchronous serial transmission. Okay, the advantage of using the asynchronous method is that no synchronization is required between the transmitter and the receiver. Synchronization is not required in your asynchronous. Okay, it is also more cost effective method. A disadvantage in your asynchronous is that data transmission can be slower. Asynchronous data transmission is slower, but this is not always the case. It can be or it may not be. Okay, and here is an example of your asynchronous serial transmission is sender will send a data, but before sending it will attach a start bit. Here this yellow 0 bit is your start bit, and this one is your stop bit 1. Okay, and in between that there is the data, this one. This 8 bit is your data, and extra 2 bit that is added. Start bit is your 0 and stop bit is 1. And in the same manner, receiver will receive that data. If this start is 0 and stop bit is 1, and in between there is a 8 bit, means that data is your accurate data that is received by receiver. Okay, if these bits are changed, 0 will get 1 or 1 will get 0, means this data get corrupted. Okay, and in between these data there are gap between data units, means this single data unit and then another data unit have a gap. Okay, and in which manner they are transmitting? In a serial manner, one bit after another. Okay, this is a serial. In your serial transmission mode, asynchronous serial transmission concept is used. Okay, further next is synchronous. First of all, I will show you the diagram. Okay, then I will explain it. In your screen synchronous transmission, it is also a serial transmission mode, one bit after another. In this, there is no start bit and stop bit. Okay, but data is sent in the form of frames. Collection of data is sent. Okay, sender will send the data. Okay, receiver will receive. But in your synchronous mode, your synchronization is mandatory. Sync. Okay, you have to sync with your sender. Receiver have to sync with a sender, or sender have to sync with a receiver. Okay, so data bits are transmitted as a continuous stream in time with a master clock, and I will give you example like your video streaming, live streaming. Okay, live video calling or your telephonic call is an example of your synchronous serial transmission. Okay, and messaging is your asynchronous serial transmission. Email is sending by a sender to a receiver is also a asynchronous serial transmission example. Okay, data bit are transmitted as a continuous stream in a time with a master clock. The data transmitter and receiver both operate using a synchronized clock. So here senders should also be active and receiver should also be active at the same time. They have to sync with each other that I am ready to accept your call, or sender is calling, receiver is accepting that call at the same time. That is your synchronous serial transmission. Okay, this means that data moves faster and timing error are less. Okay, in your synchronous, data will be moved faster because both the sender and the receiver are synced. They are present at a current time. Sender is sending, receiver is receiving at the same time. And timing error are less frequent because the transmitter and the receiver time is synced. However, data accuracy is highly dependent on timing being synced correctly between devices. Okay, so the example of your synchronous communication service is your real-time streaming media. Online live streaming is an example, like your IPTV. Okay, IPTV is there. Video conferencing is your synchronous serial transmission. Next is your comparison between your synchronous and asynchronous transmission. I've already explained that. First of all, synchronous definition is synchronous transmission. Okay, transmit data in the form of chunk or of frames. Okay, we have seen that in this synchronous transmission, your data is in the form of chunk or a frame. Okay, collected data will be sent at a time. It can be a group of 8 bits, 4 group will be there, means total 32 bits can be sent at the same time, and it is collected in the form of frame. Okay, that is why a definition is there. Asynchronous transmission is your transmit data in the form of chunk or a frame. But in your asynchronous transmission, transmit 1 byte or a character at a time. Okay, 1 byte at a time or 1 bit at a time. Sorry, it is not a 1 bit, a 1 byte. Here it is. This total 8 bit. If I'm saying 8 bit, means 8 bit is equal to 1 byte. 1 byte is sending at a time. Transmitting 1 byte or a character at a time. Speed of transmission asynchronous is faster as compared to your asynchronous, or asynchronous you can say that it is slower. Synchronous is faster, quick, and asynchronous is slower. Cost. Synchronous is expensive as compared to asynchronous, and asynchronous is your cost effective. Okay, time interval in your synchronous it is constant, but in your asynchronous transmission it is random. Random means if I am sending a mail at morning, you can receive it evening also. Okay, you can receive it next day also. That is random time interval is there. But in your synchronous, the time interval should be constant at the same time. Okay, gap between the data in your synchronous transmission, there is no gap is there. Okay, it does not exist in synchronous, but in asynchronous transmission it is exist. Okay, gap between the data, here it is an example, this gap, this one. Okay, here these gaps are there in your asynchronous transmission. Okay, but in synchronous there is no gap. Here this is a frame, but in this frame there is no gap. Example of your synchronous is your chat rooms, telephonic conversation, and video conferencing is an example of your synchronous transmission. And in asynchronous, email, forms, letters are comes under your asynchronous transmission. Okay, and this is also a diagram to clarify your concept of asynchronous. This is the sender, this is the receiver. The sender sended the mail or a message. The receiver can receive at any time. Okay, random time. Receiver can receive. But in this synchronous, if a sender is calling to a receiver side at the same time, receiver will accept that call. Okay, and this comes under your synchronous mode. And this is also an example of synchronous and asynchronous. Synchronous is your live or a video calling, okay, or a video conferencing is there. Okay, live with all participants and on at the same time. This is your synchronous is, and asynchronous is pre-recorded, enabling one to many and many to one video. Okay, YouTube video you will watch, and that is your an example of asynchronous serial transmission. Okay. Next topic is your transmission mode. Okay, this is also an important topic. Transmission modes. Transmission mode means transferring data between two devices. Transmission mode means transmitting your data or transferring your data from one device to another device is known as a transmission mode, or you can say that communication mode. Buses and networks are designed to allow communication. Okay, for this buses, further we will study network topologies. Okay, in network topologies, there are different type of topology. That first one is your bus topology. Second is your star topology, ring topology, mesh topology, hybrid topology. Okay, that you have also studied in your FCPIT subject also. Okay, buses and networks are designed to allow communication to occur between individual devices that are interconnected. Okay, transmission mode is to transmit your data from one sender to another receiver. That is called transmission mode. And there are three type of transmission mode. First is your simplex, second is your half duplex, third is your full duplex. Now we will study what is simplex, half duplex and full duplex is. Okay, this is your division of your transmission mode. First is your simplex, or you can say simple mode, half duplex, full duplex. First, what is your simplex mode is only transmit in one direction. Okay, a sender or a receiver is a single person. Okay, sender only send the data. Okay, and after sending the sender data and receiving the data, a receiver will send that data. Okay, at a single time, only one side will send the data. That is your simplexes. Only one side will send the data at a time. That is simplexes. Okay, only transmit in one direction means in one direction it can send. Like here, mainframe is your sender and this monitor is your receiver. Only mainframe can send that data to a monitor. Monitor will will cannot send the data to mainframe. Okay, so mainframe is only a sender and receiver can be anyone, but sender is mainframe. Okay, only transmit in one direction, rarely used in a data communication web TVs. Okay, it is an example. It is simplex is used in your web TVs. Receiving signal from the radio station is also an example. Keyboard and monitor is an also an example of your simplex. Okay, radio. You will listen the voice through a radio device. Okay, but you cannot send your voice through a radio. Okay, to a radio channel. You cannot send that, and that is an example of simplexes. Okay, only one side can send, other side only receive it. This is an example of your simplexes. The sending station has only one transmitter. The receiving station has only one receiver. Okay, there is only one sender and there is a receiver. Okay, here receiver in your radio station or radio concept, there is a multiple receivers also. Okay, but sender is always one that have a responsibility to send your data. Okay, next is your half duplex. Half duplex means data may travel in both direction. Okay, both direction from left to right and from right to left. Okay, data may travel in the direction but only in a one direction at a time. Okay, if sender is sending, receiver will receive that data. Okay, after receiving, then receiver will send the data to the sender side. This is your half duplex. Data can be transmit to both direction, but one at a time. Okay, data may travel in both direction, but only in one direction at a time, like your walkie-talkie. Okay, walkie-talkie is an example of your half duplex. When I will speak, you will listen. Okay, if you want to speak, I will listen it. Okay, it is an example of your half duplex. Provides no simultaneous two-way communication. Okay, it's provide non-simultaneous. Non-simultaneous means only one person will speak, other will listen. After that, second one speak, first one listen. Okay. Computer use control signal to negotiate when to send and when to receive. Okay, here control signal will negotiate who will send, who will receive. Okay. The time it takes to switch between sending and receiving is called turnaround time. Okay. The time that is switching between, if sender is sending, receiver is receiving, that time is known as turnaround time. And this concept, turnaround time, we will also study in our operating system also. There is a term used, turnaround time. Okay, that is in the part second concept. So example in your walkie-talkie, half duplex is your walkie-talkie. Okay, here are two station. If station one, this is station one, and this is station two. If station one is sending the data, station two will receive that. Okay, after receiving, then second station will send that data to a station one. Okay, this is half duplex. Okay, walkie-talkie is an example. Next is your full duplex. Full duplex is complete two-way simultaneous transmission. Your mobile phones, your telephones. Okay, these are a two-way communication. Faster than half duplex communication because no turnaround time is needed. And example is your telephones, your mobile phone. If I am speaking, you can also interrupt me in between. Okay, you can also call me. Okay, that is an example of your full duplex. Okay, there is a three types of transmission mode. First is your simplex, second is your half duplex, third is your full duplex. Okay, further there are terminologies. Channel. Okay, channel is your media or medium. A channel is a portion of the communication medium allocated to the sender and receiver. Okay, sender can send the data to the receiver if there is a media or if there is a channel. Okay, it can be wired or it can be wireless. That is your channel. Next is your baud rate. Baud is your how many times a single changes per second, means depends the number of time per second a signal or a symbol get changes. Here your 0, 0, 1, 0, 1, 1, 1, 0, 1, 1 is your baud rate. Okay, baud rate represent the number of time per second a signal changes state or varies. That is called your baud rate. Example is there. If there are 2400 baud rate, means the channel is changing a state up to 2400 time per second. That is your baud. These are the terminologies you can learn. Basic terminologies are there. Then next is your bit rate. Bit rate is your how many bit can be sent per time. That is your bit rate. Okay. Here bit rate is controlled by baud and number of signal levels. Means if baud is 10, okay, then bit rate is also 10 bit per second, and bit rate is your how many bits can be sent per time. Okay, these are the total 10 bits that is sent, and baud is your how many times a signal change. Signal changing is your baud, and number of bits that is sent, that is your bit rate. Further, last is your bandwidth. Bandwidth is the frequency range of channel measured as the difference between the highest and the lowest frequency. Okay, your internet speed is vary from your 10 Mbps to 40 Mbps. That range from 10 to 40 is your bandwidth. Okay, from the lowest to the uppest, that is your bandwidth. Bandwidth is the frequency range of channel measured as the difference between the highest and the lowest frequency that the channels put. The maximum transmission speed is dependent upon the available band. Sorry, the maximum transmission speed. Okay, your internet speed is dependent upon your available bandwidth. Okay, you will see this is an example. This is a meter is shown that from 8 to 10 there is a range, and that range is your bandwidth. Means in between that your data will be transmitted, or your bandwidth speed is in between this. Okay, that's all for today's lecture. If you have any question, you can ask me.